Hello everyone, let's continue our discussion with the in Dijkstra algorithms or linked state algorithms. Now we try to discuss about the complexity. There are two parts of the complexity. First, we deal with the algorithm complexity. So for n nodes, in each of n iterations, we need to check all nodes w not in n. So basically, we start with n nodes, okay, and then the next iteration n minus one, the next iteration one and n minus two, n minus three, and so on and so forth until we are left with only one. Okay, so basically we are summing from one to 1 plus 2 plus 3 until plus n. Okay, so it's like it becomes a sum of a series of n first integer. And if you already learn about that in algebra, or I don't know, calculus, then the sum of n first integer will be n times n plus 1 by half, okay, by 2, or it's comparable to n square. Okay, so it has n square complexity basically. With more efficient implementations, it can achieve complexity of n log n. All right, so now the second one is the complexity in the message. Okay, so each router, as we know, this link state information is achieved through link state broadcast. So each router or each node has to broadcast its link state information to or the other n routers. Okay, and the algorithm, there is an efficient broadcast algorithm, and link crossing to disseminate a broadcast message from one source. So basically, from one source, it goes through n links. Okay, so with the complexity of n, and also each router message crosses n links as well. So again, from one router, from point of view of one router, the message crossing to n links. So basically, the overall message complexity is also n square. Okay, now we'll see some other discussion. I mean, it's not an issue or problems, but it's something interesting that we can observe. So if we are considering, traffic volume as the cost, link cost, then we'll have these route oscillations in the link state routing algorithms. So for example, with this scenario, we have nodes A, B, C, D. So we are not. I mean, in this let's pass calculation. We are not calculating the path. I mean, the cost path between nodes. Like we have done before, but with the traffic volume. So for example, in A, B, C, D, there are several traffics coming to node B, C, and D, and they are all want to go to A. Okay, so from node D, there is traffic volume of 1, and it wants to go to A, so it can go directly to A. Okay, and from B, there is also traffic 1 coming to B, and then it wants to go to A, so it can go directly. And also now from C, there is traffic with the volume E. It wants to go to A, so it can choose whether it wants to go through B or through D. So eventually it chooses B. So now the traffic volume between C and B, it becomes E. Okay, becomes E, and then a traffic volume between B and A will be the it is sum E plus 1. Okay, E plus 1, because there is E from C to B, and then B to A is also E then, and plus 1 because there is traffic coming to B from other source with the volume of 1. So but if we take the other routes, I mean the opposite directions, then there is no traffic going to the other direction. So from B to C to D and to A, so practically there is only one. Okay, which is between D and A. So in the next iteration, node B and C might find that, okay, so I think it is more efficient if I try to route my traffic to the opposite directions. So now from B, it goes to C, and D, and then D, and then finally to A. Okay, and now the cost will be updated. So if before it was 0, now because there's traffic from coming from B to C, then it will become 1. Okay, between B and C becomes 1, and then traffic between C and D becomes 1 plus E, and then traffic from D to A becomes 2 plus E. Okay, so 1 plus 1 plus E. Now if we take a look at this, the traffic in the opposite direction from D to C to B and to A becomes 0, because practically there is no traffic going in this opposite direction. So in the next iteration, node D and B and C might reconsider its routing decision, so it goes to the opposite direction. Okay, so again the cost path is updated, and then again traffic in the opposite direction from B to C through D through to A becomes the next in the next iterations, and this will happen alternatively in each iteration. So this can also seen as the oscillation in the link state routing algorithms. Okay, so I think we are done with the link state routing algorithm. In next video, we'll talk about the distance vector routing algorithm. All right, so see you again in the next video.